I'm Silvana. I'm a DevOps engineer. In this video, I'll provide an overview of my GitHub Fruit project. The purpose of this project is to demonstrate some modern DevOps capabilities, which I hope will be useful to the community. I also hope that this project inspires others with ideas for when they may embark on their own portfolio projects. As a heads up, I work with AWS as a public cloud provider, and for pipelines I use GitHub Actions. Here are some repos in my crimzeek org used for the Fruit project. Firstly, let's look at Fruit project infra. In this repo, foundational AWS resources are defined for the Fruit project. This includes 3 DynamoDB tables and an AWS ECR repository. This diagram shows the names for the 3 DynamoDB tables and an AWS ECR repository, which are provisioned via our GitHub Actions pipeline. Resources are deployed using Terraform to separate dev and prod accounts in AWS. Those environments pertain to GitHub deployment environments, which are represented on the right-hand side. With foundational AWS resources already provisioned via Fruit Project Infra, it is possible to trigger the Fruit Project API Scraper pipeline. This provisions an API Scraper application as an AWS Lambda to support an ETL, extract, transform, load process. Serverless deployments to dev and prod take place as part of the main GitHub Actions workflow in this repo. Ephemeral, short-lived feature deployments are supported in the same dev AWS account as that for the dev deployment environment. This means a feature can be tested out on a PR before any commitment to merging that to the main branch for the repo. Once there is a merge to the main branch, that triggers a deployment to the dev environment, followed by the prod environment. Here, this diagram summarizes the deployment process of the application to the dev AWS environment. When there is a merge to the main branch, the main GitHub Actions workflow is triggered for the repo. First of all, there is a Docker build of the application with dependencies to produce a Docker image. It is then pushed to AWS ECR. A deployment can then take place using a serverless framework, where the Lambda is deployed as part of a CloudFormation stack. Here's an overview of the functionality of the AWS Lambda, which is provisioned. Based on a custom payload related to a target API, it fetches environment variables from the AWS SSM parameter store. It then uses this to scrape records from a target API before transforming those records and uploading those to a target AWS DynamoDB table. It's important to note that a serverless.yaml file is defined in the repo. The Serverless Framework is designed to simplify configuration for serverless compute resources in AWS. When a serverless deployment takes place, all resources are provisioned as part of a CloudFormation stack in AWS. That includes the Lambda, as mentioned before, and the AWS Step Functions State machine. Here's a visual representation of the state machine used for the project. This shows specific APIs are scraped for the Fruit project and transformed records are uploaded to specific DynamoDB tables. Arrows in these kind of architectural diagrams simply refer to the flow of data in an implementation. Finally, let's look at GitHub Action reusable workflows. This provides a compilation of reusable workflows used for the Fruit project. However, please note they are flexible to be used by other projects. Usage would depend on your use case. Workflows thus far cover Terraform Plan and Apply, Serverless Deploy, and the PyTest unit test workflow. Thank you for watching an overview about the Fruit project. The next step would be to explore the Fruit project tutorial, which focuses on using DevOps tooling and methodologies for deploying resources to AWS for the Fruit project and also testing out the implementation.